Hey, class, we're back here for number 4 of the conservation of energy questions. So what we're looking at is we have a Atwood machine where one object is going down and the other object is coming up, and we need to find out the final speed for the system. Okay, so we're going to set this up much the way we've done the other one. Okay, so as we go through this, we're going to need to know a few different things. All of the heights and all the velocities and of course all the masses. So first thing I did was I took this triangle and I wanted to find this height. How far does the car go up? Okay, and so I did the hypotenuse times the sine of theta, and that gave me the height the car is going to rise. And of course, the lead weight falls 0.85. Okay, we have our masses. And then let's also remember both cars start at rest, okay, and they're tied together. And that is what we're trying to find, is the final speed of the two objects tied together. Okay, so now we know both objects started at rest. Okay, we know the cart started on the ground and ends up in the air. And we know the mass starts in the air and ends up on the ground. Okay, so this is in the air, this is moving, this is moving, this is in the air, nothing else is moving. Okay, so now we can set that up with the space available here. Okay, you could have always put everything in, but I found in class I was running out of space. I'm trying to do this to save a little space here. Okay, so I have M2GH2 equals M2 M1GH1. Okay, and I really suggest you write down all the variables and all the initials and finals and all those things before you put the numbers in, because it's so easy to get numbers backwards or messed up or anything like that. Okay, so we're going to use these numbers we had and start plugging things in here. So M2 was 0.1 kilograms. H 0.85 meters equals 0.5 kilograms. Okay, so it ends up in the air, and that's where we introduce this. And remember, this is what we don't know. And I still almost ran out of paper here. Okay, so this is our whole string. We're solving for V. We got one equation, we got one unknown. That's a good sign. Okay, we multiply all of these together, we should get about 0.833 joules. Okay, then we got 0.6517. Okay, so now we're just off to algebra here. Okay, so there is our answer for part A. Okay, so now we're on number 4, part A. Okay, So now we have that answer based on what we have. So again, they're going to ask a similar question here for part B of finding acceleration. Okay. Okay, and now we want to take a little pause here and think about how we're going to do this. Okay, because now we have gravity acting on everything. So this is going to be a little bit trickier. Okay. Okay, so like I said, we're looking for acceleration here. We can try to solve for the car again, okay? But we have an angle, we have some force due to gravity resisting this motion, okay? Or we can do it over here. There's no angle. I just kind of like that better. I don't have to worry about sign of force of gravity. So this is just going to be m2 times g. Okay, so now we can come back and look at these. Okay, so now we can look at the sum of the forces in the y equals m2 times a. Okay, and that will get us there, but I think we're getting ahead of ourselves because we just want to know the acceleration on the system. Okay, so we're going to save this for part C. Right now, we can just do the same thing we did before. Okay, so we had 0.78. Okay, so we were getting ahead of ourselves. We had this as our final velocity, initial velocity. Okay, this is what they're asking for in part B. Okay, and our distance for this guy was still our 0.85. Okay. Okay, so we get our answer for our acceleration. All right, so we could just use that using the kinematic equations just like we did in the previous question. Okay, now we can go ahead and get back to what I was talking about before with the forces on here. Okay, so now we can look at part C, and that is going to be sum of our forces in the y. Okay, so we're going to have the force of gravity and tension equals m2 times a. Okay, so my force of gravity is, okay, what was my m2? 0.1 kilograms times 9.8. All right, this is what we're looking for, right? Part C, we're looking for the tension on the string. Okay, oh, that's all going to equal 0.1 kilograms times 0.347. Okay, so now we get our calculator again. Okay, and we get a tension. This is the opposite of our force of gravity, so you can decide how you want to do your sign on that one. Okay, so that takes us through number 4.